Good morning, everybody. So, it is like September 2nd. Man, I miss you guys. So anyway, it's difficult. Please remember to do your homework, submit your homework, okay? On non-Zoom days, please remember to do the warm-up, okay? Because it's the only way I can count you here so you're not counted out. So please do the warm-up on Canvas, and that's the easiest way for me to count you as present, okay? It doesn't have to be done until 3 o'clock. So today, what's our lesson? Well, today's lesson is graphing piecewise functions. Okay, we're going to actually graph them. It's not that hard as long as we just take it step by step. So first of all, let's talk about domain. So we need to understand what domain and range. We talked about this last year, but we're going to talk about it more specifically again. And we talked about it yesterday. Domain of a function is all possible x values, okay? And range of function, again, we talked about this yesterday, is all possible y values, okay? And we're going to look at both of these in today's example, okay? So example 1. Graph this piecewise function. So remember, piecewise functions are like pieces of graph, okay? They're like pieces. So what I have in this equation is really two pieces. Now it doesn't look like anything yet, but let's go back. We know that f of x and y really, for us, same thing, okay? We'll get more complicated when we get into pre-calculus where it becomes different. But for right now, when you see f of x, just think y, okay? So what I have is y equals 2. Okay, so that's equation 1. We have y equals 2, and I have y, equation 2, I have a y equals an x minus 3. Okay, so I'm going to graph both those equations, but since it's a piece, I'm going to put in its borders, okay? This is going to be a border line, okay? So since they're a piece, they're going to be pieced together at x equals 1. How does this work? Well, graph paper would help a lot. See my graph paper, there it is. I get my ruler out and draw a nice straight line, an x and y axis. All right, here we go. All right, hopefully you guys are watching this, figuring this out. Okay, so we're going to graph this. Remember, it's called a piecewise graph. So they're going to be pieced together. So on the x-axis, right, we're going to have x is less than or equal to 1, and x is greater than 1. So right at 1, x is 1, I'm going to put in kind of what I call a borderline. Now it's invisible. Put it in, okay. Technically it's not part of the graph, but I like to put it in. So I use my highlighter to show. Okay, there it is. So that's my border line. So one graph, one piece is going to be less than 1, and the other piece is going to be greater than 1. Okay, so how does that work? So first of all, y equals 2. Now I'm going to do it in pencil. Y equals 2 is a horizontal line at 2. Like that, right? Y equals 2 is just a horizontal line at 2, so I'm going to go up on my graph, go 1, 2. I'm going to graph my horizontal line at 1, 2. Now, I purposefully used a pencil because I only want a piece of this graph. Okay, I only want a piece of this graph. What piece do I want? I want the piece that is going to be less than or equal to 1. So I only want this piece. I don't want the other piece because my domain of this is only have it less than or equal to 1. Now, put a solid dot there because it has to also equal 1. Okay, so there's my first piece. Y equals 1. There's my first piece, less than or equal to 1. Okay, now my second piece, y equals x minus 3. Okay, so my second graph, I'm going to start at negative 3. 1, 2, 3, right? Start down here, and we're going to go, remember how to graph a line. We're going to go up 1 over 1, up 1 over 1, up 1 over 1, because that's my graph. And I graph in this line here. Now, if I don't do some erasing, then it's not a function because this is not going to work. This is not going to work. This is not going to be a function. I get two y's. But if I look at this domain, it says that keep this line, keep this piece only greater than 1. So from here, here's my borderline. Here's my greater than 1 is all of this, so I erase this back half. Now I also got to do one more thing. It doesn't equal 1, so I put an open circle right there. Okay. Here's my graph. So this is my piecewise graph. I've got y is equal to 2, but it's less than or equal to 1, so only this part of it. And I have y is equal to x minus 3, that's this line, but I only have this piece of it greater than 1, okay? It is a function. Now let's talk about domain and range, okay? Domain, all possible x values, okay? All possible x values. So x values, these are the x values. Well, this thing seems to go forever this way and forever this way. So we would say that it has everything, every possible x value. So we say this. The domain is x equals all real numbers. Okay, now another way to put that is, I like this cursive R, like capital cursive R is the symbol for all real numbers. You can either write all real numbers or put the cursive R, okay? Okay, one more time. Domain. How wide is this graph? It's forever this way, for this way, so every possible x value you could think of would be on this graph, okay? All real numbers. Now, the range is a little different because reach for your range. So the range is the y values, okay? Now the y values are up and down, okay? Reach for your range. So it doesn't have any y values down here. And it doesn't even have a y value at -2. But it has y values going up and up and up from there. It goes up, 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 up. It hits it here, but it keeps going up. So my y values, which is my range, is going to be y is greater than, not equal to, open circle, y is greater than -2. Okay, that's my domain and range of that graph. Okay, so here's my piecewise graph. I've got two pieces. My domain's all real numbers. My range starts at a height almost at -2, goes up. Up and up and up and up forever, right? Still going up. It goes up forever, it goes up forever, right? Keeps going up forever. So we'd have y is greater than or equal to -2, or greater than -2. Okay, let's look at the second page. All right, so the second page. Graph this piecewise function, okay? Well, let's go back to what I talked about. The first thing that I like to do is get what I call my border points. So these are my border. This is my border. Not my border points, but my border. Okay, so I'm going to put my border in. Let me go ahead and graph my xy axis first. Put it in nice and neatly. Okay. There. And there. There's my xy axis. That's my x. My y-axis, okay? Now, border. Let's put in my border lines where they're connected. So this is where they're connected, okay? All right. So at -5, 1, 2, 3, 4, 5. -5 is where one border point is. -2 is where the other border point is, border line is. And then +2 is where my other border line is. So I'm going to put those in. These are my connect or my border lines because I'm going to have pieces. I need pieces, and my pieces are going to fit within these boundaries or borders, okay? It's called a piecewise graph. So I'm going to have pieces within these regions, okay? So I put in my border lines, -5, -2, and 2. Okay, now, f of x. Remember, f of x and y are the same thing. So we get y, first equation is y equals 4. Okay, my second equation is y equals x squared. And my third line is y equals x plus 2. Okay, these are my graphs that I'm going to graph. Okay, so I'm going to have 1, 2, 3 graphs within these borders. Let's do it. So y equals 4, first graph. Y equals 4 is a horizontal. Remember, that's a horizontal line at 4. So I go up to 1, 2, 3, 4. And I graph y equals 4, except I don't want all of this. Okay, y equals 4 is too wide. I only want a piece of it. What piece do I want? I want the piece between -5 and -2. So I only want this piece right in here. I don't want any of the rest. I'm going to erase all the rest. I only want that. Get rid of that. Get rid of all that. I only want this piece right here, okay? So I want this piece here, to here, except I gotta be careful. It says it equals -5, solid dot. See that little equal sign? So x is gonna be greater than or equal to -5, but there's no equal sign on -2, so it does not equal -2. So at -2, I put an open dot, open circle, okay? Okay, let's look at the second graph. Now y equals x squared is a parabola, okay? So a parabola is going to be like this. Parabola has this shape here. Okay, it touches there. And the way the parabola works is at 0, 0 squared is 0. At 1, 1 squared is 1. 2, what's 2 squared? What's 2 times 2? 1, 2, 3, 4. 3 squared is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. But I'm not going to put that in because I'm past my border. Okay, does that make sense? Now, -1 squared. -1 times -1 is +1. -2 squared, -2 times -2 is a +4. 1, 2, 3, 4. Okay, and I'm not going to go any further because that's not within my border. Okay, so let's connect. Okay, so this is what this parabola looks like. Okay, there you go. And let's see now. At -2, this parabola equals -2, so I'm going to put a solid dot now because it fills the hole. And 2 here, I'm going to have an open dot because it doesn't equal it to 2, okay? Had to do that because I can't count this point twice. We'll talk about that even more later. Okay, so here's my graph. Last piece, okay, last piece. Y equals x plus 2, okay? That's a straight line, has a slope of 1/1. Okay, let's figure out what this looks like, okay? So I'm going to start at 2. Just right here, 1, 2, right? And I'm going to go up 1/1, up 1/1, up 1/1, up 1/1. Okay, so my line would look like this, except for I don't want all of this. I don't want all of this because that's not a function. I only want the piece that is going to be greater than or equal to 2. Here's my borderline. I only want this piece right here, okay? That's the only piece I want, so I get rid of all the rest. I can't have that anyway because it wouldn't be a function, right? So get rid of all that. Greater than or equal to 2, so I can put a solid dot, and there's my graph. So it's this weird looking graph like this. Check that out. It goes from here, scoops in a parabola here, and does a straight line there, okay? Now, domain and range. Domain is all x values, okay? Or sometimes I like to say, how wide is the graph, right? So how wide is this graph? Well, there's nothing over here. There's no graph over here. But it does start at -5. X equals -5 and just goes over forever, okay? So I'm going to say my domain is x is greater than or equal to -5, okay? So my domain, my graph starts at -5, just goes over forever and ever and ever because this arrow here keeps going forever, okay? Now, range. Okay, remember, range is all y values, okay? So if it's all y values, then what I'm doing is looking at how tall, or another way is to think about how tall is it. So this graph starts at 0, it touches at 0, and then it goes up and up and up and up, because this arrow here goes up forever. So I'm going to say y is greater than or equal to 0. Okay, so that's what I have for you for today. Homework is page 10 in your journal. There are 4 graphs I want you to do, and there will be an extra along with your homework when you see it, okay? It'll probably be graphing something with a parabola in it, okay? All right. That's what I got.